Okay, so in engineering, one of the things you'll do is work with, there we are. You'll work with scientists and other people who write down equations on paper because it's very quick and intuitive. Your job as an engineer, depending on what type of program you're working in, is to convert this into a program where you can repeatedly do something very accurately, which is MATLAB is one of those. So what we're going to do is take this stuff written down on paper, convert it into a MATLAB program where it can be more accurately and done faster. So we want to get our MATLAB program going, which is at mathworks.com. And if you're already logged in, which you might be if you're on your own laptop, otherwise you'll need to log in. And I don't know, okay, I'm already logged in, so I'm going to go into MATLAB, open MATLAB online, and get back to where we were the other day. And I need to find the assignment. Oh, there it is. Otherwise, I won't know what I'm doing. There we go. All right, got it. And things I don't need. There we go. Open MATLAB online. And of course, the first thing I do, because I know about computers and I do not trust them at all, is save my file. And I have backups upon backups. No one ever calls me and says, hey, my computer's working good. So we first, oh, this is another file I was working on for something else. So if you don't have an open file here that is empty, you can create a new script by going over here and clicking new script. By default, which means that it's going to do this automatically, it gives you the name untitled, which is not very descriptive. We're going to go to save and save as. If anybody gets behind, please say I'm behind, just stop for a second. Otherwise, I will keep going. Don't be afraid to stop me. Okay, so I don't know if I put a name for this. Sometimes I do, sometimes I don't. Nope, in this case, this is more, what we're going to do is, right now, I'm giving you the step-by-step on how to do this. This is the process that you will continue through the entire semester. So when programming and anything else, you want to do things consistently. If you have a framework or a process, which engineering is all about processes and procedures, you can repeat something over and over again. We will not be writing the same programs, but we'll use the same process to create our programs. So since the name of the program is work, and, oh, just a second. You have to have a special name when you're doing the grader. I can't remember what that is. We'll find out, we'll just have to rename it. So here I would save it as work and force done. So the whole grader thing is something Arandi discovered and has been implementing, and we haven't used it very much yet. So we're still figuring out how it works. So you're the beta testers. Work and force done, you go ahead and save it. There we are. Now the problem says, get mass in pounds, acceleration in feet per second, and distance from the user. Well, we know we can't get all three of those at once. And in programming, we use words. So I would probably go like this, mass equals, and remember, programming is flipped over when you're doing math. So if they have a formula here that says something or other equals something, you flip it over and you assign the calculation to the variable. And in this case, what are we going to use to get mass from the user? What's our command?
Input.
Input, exactly, Mente. And in here, it even says, enter a value for the prompt, and it shows you that it wants double quotes. Because the prompt is text. So you just say something simple like enter mass. Notice that this and this are the same as the words that we were using. So in programming, we're not doing general things. We're doing specific applications. The general formulas are what Arandi did. These general formulas can be applied to any number of problems. What we're doing in programming is doing a specific solution. And you would repeat this 3 times for each of them. And what I showed last week was you could select it, copy, Control C, paste, paste, change the names. That's called a dry solution. Do not repeat yourself. Okay, I think that's right. Oh no, there's only one L. MATLAB does not have a spell checker. And distance. And if you are commenting, like Arandi said earlier, in programming, we add comments, but not necessarily to each line. We add comments to show people what's going on who work in the program later. And I've mentioned that programs have the same cycle every time. You have input, you have calculation. Most of the time you have some sort of output. Most of the time you have an input. Because we'll do problems where there isn't some of those. So this would be get input from user. So this program uses input. Sometimes you will do what's called hard coding, meaning you just type in numbers that you know what's going on. Is everybody good to this point? If you're not, let me know. If you're lost at this point, don't hesitate. There are no dumb questions, except, is that a door? That would be a dumb question. Is this a TV? That would be dumb. Unless you're an alien from Mars, in which case it would be a good question. Okay, we get, oh, what am I missing here? It says in pounds. Yep. Because we need to do unit conversions next. Because is pounds and SI? No. You're right. And A to math people means acceleration, which engineers are math people. Oh, feet per second squared, sorry. Did the wrong thing, I need my units. Per second, well, that makes a long prompt, but it works. And for distance, we have feet. So now we know the units that we're entering in. And obviously this is the United States because we're about the only country that uses imperial units anymore. Everybody else has gotten smart and gone to metric. But we're special in the United States in so many ways. So far, so good? If not, let me know. We are going to convert now because we need to convert from, whoops, I'm in Python, there. We need to convert from imperial units into SI units. In this case, metric, be specific. I think I did everything. Yeah, and actually I have an assignment. I have it says get mass, assign mass. I have like too many things in there. I have it done twice. Okay, so we're going to do conversions next. We're going to convert the mass from pounds to kilograms. You can look it up on the internet, but here it is. So if 1 pound, which is what's coming in, is 0.454 kilograms, what is our math formula to convert this to kilograms? What would we calculate?
Mass times that.
Yep, and usually what I do is I copy out the formula so I don't have to look at two things. So I've selected it with my mouse. I do Control C to copy it. And I will paste it in here with a comment sign. So then I can see the formula. That's supposed to be a G. Sometimes things go across weird. There. Because we know it's supposed to be 1 pound to, oh, okay, I don't know where that came from. Okay, so when we convert this, we could have different variables that say mass underscore P for pounds. Or we can just use mass down here and overwrite that same variable. Later on, we'll get fussier with naming. Now we're not going to be fussy. So if we need to convert mass, we're just going to say mass, which will now be in metric where before it was in pounds, and we can do that. We can take mass times, what was it, 0.454, yeah, 454. Will that give us the correct conversion? Yes. Even if you don't know the answer for sure, be confident in your responses because people may just take your word for it. Now we do the same thing for acceleration. We use acceleration as our variable name. Oh, I should go through that. At this point, the mass variable holds things in pounds. We can make a calculation with that variable. As soon as we assign this value to here, this is now in kilograms. It's the same variable. We're just storing different numbers. We could have named it something else, but we didn't. Let's keep it simple. So we're going to have acceleration equals, acceleration. And how do we convert that? First thing I'm going to do is, we'll do 1 foot per second and do that one. I like the ones where you multiply just because it's easier for me. I'm not an engineer. Computer science people. Okay, that was weird. Oh, I got extra numbers in there. There we go. There was enough. So we do feet per second. We're converting it to meters per second. So my formula would be acceleration equals acceleration. That's my formula that I would use. I'm using parallel structures on this, so each one of these is going to be multiplication. We don't want to mix up methods of conversion because we want the conversion signature, meaning the shape of it, to be the same. So it'd be 0.3048 semicolon. And this should be in a different place. There it is. But oh, that should be. Boy, I need to paste this in the notepad first. Yeah, we'll get to that later. And we do the last one, same pattern. Copy the 1 meter equals 3 point something feet. And we have extra weird things. There, oh, actually that's pretty good. So we have distance equals distance times 3.281. So by being consistent, we're doing the same type of conversion. You wouldn't want to go between one and another and divide in one and do something else in the next. Consistency means I can look at this code very quickly and see what's going on. And you won't be always writing programs from scratch. Quite often, you'll be looking at somebody else's program and trying to figure out what they did, which can be very challenging. So far, so good, and I can tell by the typing that either you're behind or you're ahead. Let me resume recording. Now we're going to do our calculations, because we have 2 of them. Well, we'll just do this one as, this is net force. Net force calculation. And I'm going to paste in my formula. If I got a piece of paper from somebody, I'd have to, write it down. So there's a couple different naming conventions. Convention meaning that everybody agrees to this, and you want it to be consistent as far as naming variables that have more than one name. One way to do it that I use a lot because I program in Python a lot is called snake case. Can you see why it's called snake case? It's like, like a little snake going along. So there's my variable name. I'm going to take mass times acceleration. Well, that's just way too easy. I don't have to ask anybody how to do that. You should already be done with that one. Oops, there we go. One down. What's our next one? Work done. Work done. Which work done is the result is in what measurement?
Joules.
Good.
Why can't you just multiply the mass and the acceleration times the distance to get work?
Because you want two different answers.
You do want to do that?
Yeah. And another reason is that in programming, we try to do one thing per line. It's called single responsibility. You do one calculation per line and it's easier to troubleshoot. I can narrow down, is it this calculation or the next calculation?
Yeah.
In Python, there's like this big competition to do as much in one line as you want, which is absurd because how do you troubleshoot that? I do a lot of debugging because I get student assignments and that doesn't work. So the single responsibility principle means you do one thing per line and that's it. You don't do anything else. And that's the reason, is figuring things out afterwards. And if I have a bunch of calculations at once and I'm come back even a month later, I don't remember what I did. It's called the Alzheimer's law of programming, which is not really a good name, but that's what it's called. So we have work equals force D. And that was a good question, Nicholas, because that brought up the whole thing of the logic behind how we do things in programming, possibly different than you do in math. Right? Because in math, you may do a bunch of things in the same line. No? Yes?
Yeah.
I don't know. I'm not a math or a science person. That's where Randy's here.
You gotta
Engineering.
do a whole lot all at once in math.
Yeah, and in programming, it's difficult to debug. Because then you have to figure out which part of this line is not working. Now I can figure out, okay, this part is not working. I can fix that. This part is not working. So it has to do with workflow. All right, so we have work done. Uh-oh, we're in trouble. Do we have to do any conversions? Oh, no. We have to do some conversions. Uh-oh.
I thought you did.
I did for mass. I did for acceleration. Oh, I don't have to do it for net force, do I?
No,
Yeah, it's all.
you're good.
Why do we have the conversions a second time then?
Why do you have a distance multiplied by a 3.281?
Because it takes your feet and converts it to meters. You should be dividing it, but
I thought distance.
Did I do
was
the
in
wrong
meters.
one?
Yeah, in the assignment, it says enter distance in meters.
Yeah, it says enter distance in meters.
Oh, okay, sorry. So what's it supposed to be?
It's just whatever you enter.
You just-
distance.
Oh, so we have the conversion in there. We don't need it.
No.
You can just delete those two lines.
Yep, okay. I think we'll get rid of them because we don't need them. Sorry, I was following my directions, as obviously they were done by someone who knew nothing about the assignment. Well, that'd be me. So these are already converted. The other one's in the right force. We don't have to convert it again. And for some reason, I'm converting it again. So no, my PDF document is flipping around is what's going on. I'm accidentally seeing things twice. Okay, so we have net force. Yeah, see, it is wiggling.
So now we have to do work done.
There it is. I was finding it because after work done, for some reason, I have conversions again, which would be not be what we're going to do.
I think there's a way to close all processes.
Okay, sorry. I don't know where it is. If you run things too many times, there is a way to stop it. If you have the command line open, you use Control-C. Is that what you mean?
Yeah, he had the same issue that I think Lily was having the other day.
Yep. And if you have it in for some reason, I closed mine out. You would use Control-C to break any command line thing in Windows. That usually will stop it, or you have to continue the thing. All right, so work done. I'm going to use the same that I did before, the same naming convention. Whatever naming convention you use, be consistent. Equals, where's my net force? Times, and D is distance. There. I am not going to get complicated at this point in doing the conversion. I am not going to like make it fancy and make it look pretty. All I want to do right now is see, does the calculation work? I can make it pretty later on. And so I always put in test numbers that most of the time are correct. I have had students find formulas that I messed up, especially in this class, and these are not the right answers. Just FYI, if you find a wrong answer, let me know. So we're just going to use display for right now, just to show what the answer is. I am going to put in what it is, otherwise I don't know what's going on. So the first thing that I want to do is, Acceleration, okay, work done. Yeah, that's our ultimate thing. Yep, work done. And then comma, and then I'll put in work done as the variable, and now we can do a beta test on it and see if it works. Then you can make it look pretty later. How's everybody doing? So far, so good? Okay. All right, well, let's run it. This is a single program. We don't have to put sections in it. We can go ahead and run it. Enter mass in pounds. I'm going to look at my sample, which has 20.3. And I'm going to do feet, 12.3 feet per second squared. And I'm going to 25 feet. And something went wrong. Well, I don't remember the syntax.
This display doesn't take two inputs. You have to use either plus or use F
Okay, yeah, that's the problem with knowing too many languages. I forget which things go where. Thank you, Landon. One more try. And if you do get stuck in here and you want to just kill it, Control C should kill everything. Hold down the Control key, type C. That breaks the command line flow. All right, let's run that again. Use the same numbers, 20.3, 12.3, and 25. Huh. It should be, oh, this is not right. I have 263.05 and this is 8663. What did I do wrong?
Do the calculation by hand. And
Are
then have a calculator.
Are you kidding? Oh, you mean them?
Oh, them, they should know. I went through it by hand.
Okay, I'm gonna,
You should make math guide.
This is why sometimes that's good to do a sketch. You need to write down, you should have a framework because who knows if the program is wrong? Are you going to trust that number, 863? How do you test it?
You do a thing. You go find someone there better calculated than you.
okay, it's starting in pounds, so that would be right. It's starting in meters per second. Guess I need to find my answer.
Nice. Is the conversion rates correct? So let's go back.
That's what I was looking at, because I'm gonna look at my answer.
0.454,
Nope, that's not it. I'll have to find it from my USB drive.
or maybe the answer you had there was wrong.
It could be.
Yeah. So let them do the calculation
Okay,
and see.
that sounds
It's a
good.
simple calculation. What did you enter for mass? Bill, what did you enter?
Oh, let me bring up the sample
20.3.
problem. The sample problem is 20.3.
Now that's pounds, so you
Right.
have to do the unit conversion by multiplying by, nobody has a calculator?
What? I don't have a calculator.
So you should have a calculator then.
Well, right here, 20.3 times 24.
Can you go back to the unit conversion so that they can do the unit conversions?
There we are.
0.454, then feet,
I should have these right next to each other,
Yeah.
shouldn't I?
12.3.
12.3.
0.308.
And then this your last value, then 25 is this.
It's in feet, so we do need to do a conversion.
Yeah, we did the conversion.
Oh, I took it out because I
Oh,
thought,
yeah.
No,
Oh, you got a different conversion,
Yeah.
because
Oh.
there's the feet per second squared and meters per second squared.
So that's good. Then you.
I took out the wrong conversion.
No.
No, you took out the right one.
Right,
I think your answer's right. What I got was that as well.
yeah.
And on your calculator, you got the same thing, 863.
Do something different.
So did you get it, Gabriel?
No, right here.
Just because it's programming